All right. Ibrahim, Adilhan, welcome. Good to see your names in the screen
Good
again,
evening.
Ibrahim. Ibrahim, how are you today? You feel fresh yourself or tired?
So tired.
So tired. Did you eat your
Yeah.
dinner?
Yes.
What did you eat? Soup or
Meat.
meat? What kind of meat?
Yes.
Meat from cow or sheep or goat, or
I don't know. Well, I know it's meat.
how much did you eat? A lot?
Yes. Very.
Oh, I
For
see.
me.
So our class will be like a lullaby for you. And I'm sure that you will fall asleep soon. Adilhan, how about you? You finish your dinner?
I didn't even eat it.
Really? Why not?
I don't know.
So you're not hungry now?
No.
Good. Okay then, guys. Let's continue. You just have a rest. You know, it's online class. One good thing about online class selling, you can make your tea and just keep it on your table and just lean against your chair and just try to make yourself comfortable with the class and just watch. Okay, if you feel bored, you ask a question. That is how we do online class. Okay, just try to yourself active. Otherwise, you will feel bored and you may feel sleepy. Okay, and if possible, turn on your cameras. If not, okay, it's okay. So guys, last time we were solving questions from our test two. As you remember, 2 or 3 questions were left, and we were discussing question 12, and we just ran out of time, and we had to stop. So let me just continue from here. We have 2 more questions. I just put them here so that I have more space, and also you can see these questions much better, right? Clearly. Okay. So question 12, it is about sets. Okay. Here in solving questions, before I move to this question, let me just write something because sets is different topic. Maybe you have some idea about sets. Maybe in the future we will learn this together after 3 or 4 chapters. Okay. So I just want to tell you something. If you are talking about 2 different types of people, okay, let's say one guy guys chocolate, another guy likes, for example, what is it, uh, candy, something, right? So if you're talking about 2 people, let's say, let me just write here, 2 different, okay. And here we are talking about, let me just write here, math and English, right? So let's say the number of people, if I just denote here, what does the intersection part? That means that the elements here, right, intersection part, it belongs to M, it belongs to E. What does it mean? It means that if you are talking about math and English, those people in this intersection part, they like math and also they like English as well. And how about this part? You let me just write here, X, and this part is Y, and this part is Z. Usually here, this X, right, it belongs to only M. That means that X people or students like only math. And how about Z? Z represents that the number of people who likes or who like only English, right? And Y, actually Y is the number of students who like math and at the same time who like English. All right. So now if I just write here, usually when you talk about set n of m, what does it mean? It means that the number of people who like math. So that means who like math, it is, I'm not saying only math. Math, right, is x plus y. And how about the number of people who like English? And again, I'm not saying only English, we are just saying English. That is y plus z, right? And how about the number of people who like math and English? Math and English. How do we show this? By says, actually, we just show this by math, and this one is and English. That means that the number of people who like math and English, that is y. Okay, now from here, and also we have another symbol here. Let me just write number of people who like math or English. Okay, this English means it is not we use in our daily life. That is or in math. Okay, for example, here, if I just say that, okay, I'm going to supermarkets and I'm going to buy pear or apple. Okay, and I just came back home and holding only pears. And now what is the result here? Actually, I didn't lie, right? I kept my promise because I said I will buy pears or apples. And how about if I buy only apples? Still, actually, the result is true, right? Because I'm not lying here, because I said either or apple or pear. And how about if I buy both? Still, actually, the result is true. It is something like this. Here, M union English means the number of people who like math or who like English or both. That it means this. Now from here we know that that's equal to, if you look at the picture, that's equal to x plus y plus z, right? So that is equal to this formula, number of people who like math plus number of people who like English. And when you just write this one, what is this? It is x plus y and number of English, y plus z. As you see here, y is counted twice. So now we should subtract minus number of people who like math and English, right? It just gives us the total number of students in the class. Now using the same thing, now I'm going to write one formula, and using that one, we're going to solve this problem. Let me just duplicate this because I need some space here. Okay. All right. Now, how about if we have these three sets here? We are talking about three different subjects, right? At the time here, I can just write here number of people who like math. Okay, let's well, this one is math or English or science. That is math or English or science. That is equal to the number of people who like math plus number of people who like English plus number of people who like science. Now minus number of people who like math and English. Minus number of people who like math and science. Minus, here we have number of people who like English and science, right? And now plus, when you just count this, actually this common part is counted 3 times actually. Here, from here, we counted 1 time and 2 times and 3 times. And here we have 1 time, 2 times, 3 times. So I'm talking about the common part to all these circles. So that's why I need to add one more thing here. Then here we have plus number of people who like math, that's A. They like math and English and science. Okay. So in this question, number of among 64 students all together, here we are talking about 64 students, right? That is 64. Now number of math, how many people like math? It says 41. So number of people who like math is 41 plus number of people who like English, that is 20. Here it is 20. And number of people who like science, it says 28. So that is 28 minus number of people who like math and English. And math and English, that is 24 of them like both math and English, that is 24. Minus 12 students like both science and English, that is 12. And 10 students like both science and math. So here we have 10. And plus, the last thing is how many people like all of these subjects? We don't know. That is a question here. That's equal to X. Okay. Now from here, we know how to solve this equation. On the left-hand side, we have 64, 21 plus 20, 41 plus 20, 61 plus 28, that is 89. Minus 24 plus 12, it is 36, plus 10, it is 46, plus X. Now from here, what is X? 89 minus 46, that's equal to 43. And 64 minus 43, that's equal to 21. That means that under these conditions, then 21 people like all of these three subjects. And Celine, I think you also solved in this way, but not using this formula. Is that right?
I think so, yes. But what is the use there?
You
I didn't
actually
get it.
here, this one, we have this one, we call this intersection, the common region.
But
And
what
this
does it
one,
do?
we call this union. Okay. So union in our daily life, it's like or. And this one, intersection, means and, right? That means that here, to be in this region, intersection, you must like both. This union means either who like math or English. That means that we are actually considering all the people here, right? Now, if I look at this, this X, the number of people who like only math. This Y means the number of people who like math and English, that is intersection. And Z is the number of people who like only English. Now, how about the number of people who like math and English? That's, we are talking about this union. So M union E, this all these numbers, X plus Y plus Z, right? So here we have number of M union E, that is, here we have X plus Y plus Z. Okay, that's just one example. Maybe in different way also you can solve this. And again, we will learn about sets in detail in the near future. Okay, that is in chapter 11 or 12, I think. We will learn about this. Okay, so let's continue then. If you have any question about this, you may ask. Otherwise, we will continue. Okay, so the answer is 21. Another question, it says that evaluate the following using a simple methods. And I was expecting you to show your methods and Celine only. I think other people didn't submit their work. Celine, once again, can you tell me how did you solve this problem?
I didn't choose this problem even. I don't remember just because it is test 2. Because I have just it on photo because I lost it on paper.
Okay, no problem.
I don't remember.
Okay, here, maybe if you have a calculator, you can just insert all of these numbers, calculate this number 1. Number 2 is you can remove the brackets and evaluate this. We can do also in this way, right? But here it says it's just simple method. So I will use algebra to solve this one, okay? Let me just denote this thing, okay, as X or just A, doesn't matter. Let's say this X. X equals 1 plus 1 over 3 plus 1 over 5. And how about this number? Let me just denote this by Y. This one is X, this one is Y. What is Y? What we are doing here is just labeling, okay? I'm saying that, okay, this expression, I call you X. Another expression, okay, look, I call you Y. So the second one is 1 over 3 plus 1 over 5 plus 1 over 7. Now, let me just say that also the whole expression is capital A. Now here I'm trying to find capital A. So now if I write capital A in terms of X, the first one is X times, the second one is Y minus. What do we see here? As you see here, 1 plus 3 plus 5, right? Or I can just write it as 1 over 3 plus 1 over 5 plus 1 over 7. What is that thing? That's equal to Y, right? So I can just write here 1 plus Y times. How about 1 over 3 plus 1 over 5? As you see here, 1 over 3 plus 1 over 5 using the first expression, right? If you just take 1 to the left-hand side, we will have that thing. X minus 1 will be equal to 1 over 3 plus 1 over 5. So here, that is equal to 1, not 1, X minus 1. Okay, 1 over 3 plus 1 over 5. Now, if I simplify this, here we have X times Y minus 1 times X, it is X. 1 times negative 1 with this minus, it is plus 1. And y times x, yx with this minus, it is minus xy. Y times negative 1, it is negative y. With this y, it is plus y. Now, as you see here, we are saving a lot of time by just using simple algebra. This xy, they cancel each other, right? And what we have here is y minus x. So here we have y minus x, and here we have plus 1. Okay, now from here, okay, y minus, okay, all right, let me just substitute now, I think. All right, what is y? Y is 1 over 3 plus 1 over 5 plus 1 over 7 minus, how about x? It is 1 minus 1 over 3 minus 1 over 5. Now here we have plus 1. As you see here, 1 over 3 minus 1 over 3 is equal to 0. 1 over 5 minus 1 over 5 is equal to 0. Negative 1 plus 1 is equal to 0. So the whole thing is equal to 1 over 7. As you see here, I did not multiply any two fractions here, right? But I just used simple algebra and just labeled some expressions by x and y and substitute these numbers into here and evaluate this. So the answer is dot, dot, dot. The result is equal to 1 over 7. Let me just check the chat box. Somebody is asking something, I guess. I like bar 1. I like bar 1. What do you mean 1? Yes, I like bar. Alekbar, can you hear me?
Yeah, teacher.
Yeah, why did you say 1? What do you mean?
I think he wanted to say the answer for the one you said, like x minus what, and he said 1, but you didn't. So at that time, that's why.
I see. I like, but you can just speak directly, because when I'm writing each time, opening the chat box and check this, it's not so comfortable. Okay, you can just say Mr. Qasim, it is 1 or minus 1 over 7 or something. Okay, all right, that's our last question. And again, guys, our topic is algebraic equations and inequalities. So every time we try to solve questions using algebra, because algebra, as I told, is very, very powerful and useful tool. And with the use of algebra, we can solve a lot of almost every complicated problem in physics, in biology, in chemistry, in math. Okay, so that's why here, try to solve every question using algebra, because here our topic is algebra, fundamental algebra. Anyway, the sum of the digits of a 3-digit number is 18. Okay, so the 10th digit is 1 more than the 1st digit. If the 100th digit and the 1st digits are swapped, it means interchanged, right? The difference between the new number and the original number is 396. What is the original number? Okay, that is a bit pure math problem. Okay, at once you may not understand this. You have to read again and again and again. And if you don't understand, just write that number and try to understand. Okay, sometimes reading again and again, it may not help. At the time, you need to draw a picture. If it is related to geometry, draw a figure. Okay, here, let me just start from the first part. The sum of the digits of a 3-digit number is 18. Okay, so what is the 3-digit number? I don't know. Let's say the 3-digit number is A, B, C. That is our 3-digit number, right? So that is equal to, and here we are talking about this 3-digit number. In the question, it says that the sum of the digits. What are the digits here? It is A, B, and C. So the sum of these numbers, A plus B plus C, is equal to 18, right? So this A, B, C are numbers between 0 and 1. Now the 10th digits, if I write here, let me write once again, A, B, C, right? And we know that starting from the right hand side, so this C is in 1st digit, B is 10th digit, it is 100th digit, and we'll continue 1000th digit, 10,000th digit, blah blah blah, right? And also let me just write immediately here, we know that if it is 17, not 17, let's say 27, I can write it as 2 times 10 plus 7. Now, if we have 237, for example, 7 is in units digits, units place, right? 3 is tens digit, 2 is 100s. So I can write it as 200, that is 2 times 100, plus 30, that is 3 times 10, and 7 times 1, that is units digits, right? It's just 7. Okay. In similar way, if you're given ABC, I can just write it as ABC, that's 3-digit number. I can write it as 100A, that is A times 100, plus 10B, that is B times 10, plus C times 1, that is C. Okay. All right. So the tens digit is 1 more than the ones digit. So we are talking about tens digit. Here we have B, and ones digit it is C, right? It says tens digit is 1 more than the ones digit. That means that B is equal to C plus 1. So B is tens digit, C is ones digit, right? So that is 1 more than the ones digit. Okay, that's the second condition. Now, as still it continues, if the hundreds digits and the ones digits are swapped. So now I form new question, new number. That's the second part. I'm just switching, get the ones digit and 100s digit. Then we will have this number, C, B, A, right? I'm just swapped actually the tens and the, hundreds and units digit. Swap, the difference between the new number and the original number is 396. So that means that the difference between new number. So that is difference between new number minus the original number, that is ABC, that is equal to 396. What is the original number? So we have to find that ABC. Okay, the question is, what is this ABC? So that is what we have to do. Okay, if you understand this part, I'm going to clean and I need more space. Until here, Adilhan, Alakbar, Selin, if you have any questions, you can ask, okay, which part you didn't understand. That's the most important step. And after that, just we need to solve this question. All right, let me just simplify this. Here, since B equals C plus 1, if you substitute into the first equation, now we will have here A plus, what is B? B is C plus 1 plus, and here we have C that's equal to 18. Now from here, A plus 2C, 18 minus 1, that's equal to 17. Now I have something, the relationship between how A and C are related to each other. And also we know the relationship between B and C, right? And from this, how about from this? Let me just write this in blue. So again, the CBA, right? We can write it as 100C plus 10B plus A, right? Minus, how about ABC? We can write it as 100A plus 10B plus C. That's equal to 396, right? So now if you simplify this, 100C minus 1C, that's equal to 99C. And 10B minus 10B is equal to 0. A minus 100A, that is minus 99A. And how about 396? We can write it as 4 times 99. So here, if you divide both sides by 99, because I can write this one as 99 times C minus A is equal to 4 times 99, right? So this 99 cancels each other. What we have here? Here we have C minus A is equal to 4. Okay. Well, from here, I can find C. What is C? It is 4 plus 8. All right. So now I will substitute this value into this equation. Okay. If you substitute here, A plus 2 times, what is C? It is 4 plus A is equal to 17. So now we have to solve this equation. 2 times A, 2A, A plus 2A, it is 3A. 2 times 4, 8. Take to the right-hand side, 17 minus 8, that's equal to 9. So from here, what is A? A equals 3. Now I can just write the answers here. So A equals 3. Now if you substitute here, if A equals 3, C equals 4 plus 3. So here we have C is equal to 7. If C equals 7, B equals 7 plus 1. So here we have B equals 8. So dot, dot, dot. I mean, the answer is, what is it? 387. So we are talking about this number. Guys, any question?
No.
Okay, good. And that's all about this test. Okay, and next time, Selin, maybe you can discuss test 3 questions. Okay, so guys, let's have break for 3 minutes only. Okay, after 3 minutes, we will continue our class. All right. Okay, guys, let's continue. As I told you, after this test, we were going to study geometry for a few weeks, maybe 2 or 3 weeks. Chapter 8 is about perimeter and area of simple geometrical figures, or just simple geometric figures. And after that, chapter 9 will be about volume and the surface area. Okay, so today, I mean, for this week and next week, we will talk about these 2 topics. All right. So what are we going to learn here? I mean, study here. Number 1, for as you see, the name suggests that we are going to talk about the perimeter, and we are going to talk about very simple geometric figures. What are those simple geometric figures? Triangles, right? Quadrilaterals like rectangles, squares, maybe rhombus or kite or trapezium, parallelogram, these kind of shapes. These are basic but the most important geometric shapes in geometry. And after that, we will talk about the area, how to find the areas of these simple, important geometric figures. Now, we know that actually in primary school, right? And I'm sure that you did a lot of examples, but simple examples about the perimeter and area. So when we talk about perimeter, we mean the length of the boundary of flat shape, right? If you're talking about triangle, for example, we know that triangle has 3 sides. What is the length of the boundary, right? If you're talking about square, again, it has 4 sides, right? We need to just measure all the sides and add them up, and we get the perimeter. Okay. And how about the area? A part of the plane enclosed, right? A simple closed figure is called a plane region. And the measurement of plane region enclosed is called its area. Anyway, so actually in real life, we know that a lot of times we need to know the area of something, right? For example, if you're going to paint your house walls, for example, you need to know what is, I mean, how many square meters we need to paint, right? If you're talking about, for example, football field, right, what is the area if you're going to plant some kind of grass, or tennis court or badminton court, right? And some kind of big fields, this kind of stuff. Actually, we need to know some, how to say, and some knowledge about these measurements. Okay, here what you have already learned, square, we know that it's a special quadrilateral where all sides are equal. At the same time, interior angles are equal. And what is the area of the square? It's just A equals X squared, right? X is the length of one side of a square. And how about the perimeter? That means the length of the boundary. If we have a piece of land in square shape, right? If you want to enclose this piece of land by a kind of fence, for example, you may wonder how many meters of fence you need to buy from the market, right? From the, anyway, any shop. So to answer this question, you need to know the perimeter of this square. That is x plus x plus x plus x, that's equal to 4x. And how about a rectangle? Rectangle is also a special quadrilateral, right? Whose opposite sides are equal and all interior angles are 90 degrees. But not necessarily, actually, the sides must be equal, right? Opposite sides are equal. So usually the longer side, we call this length, right? This is L, length. And also this side is length. And shorter side, we call this width or breadth. That is B. And also this side is B. So the area of the rectangle, it is just length times width. That is L times B. How about the perimeter? L plus B plus B. That is 2 times L plus 2 times B. Or also we can just write it as 2 times length plus breadth. And how about the triangle? Triangle also, it's a flat shaped geometric figure, right? Which has three sides. It is closed, and those sides are A, right, and B and C, or let's say A, B, and C. And how about this H? H is the height. Height means the shortest distance from B to the line AC. We call this a height, right? So how do you find the area of the triangle? That is 1/2 times B times H. That is base times height. Why is it so? Because using two identical triangles, we can always form as one rectangle, or let's say parallelogram. That's why it's just half of this figure. So how about the perimeter? That's just A plus B plus C. And how about the circle? And we know the circle is a geometric figure, right? And its definition is a set of all the points in the plane which are equidistant from a fixed point. That is the center of the circle. And the distance between the center and to the circumference, it is a radius. And the area of the circle is pi times r squared. We know that pi is a constant number. Usually, in most problems here, we will take pi as 22/7, which is approximately equal to 3.1428, blah, blah. Okay, and how about the circumference? Circumference of the circle is 2 times pi times r. Okay, 2 pi, these are constant numbers. Anyway, it's just revision. So now let's talk about area. Okay, usually when we just talk about area, first we have to introduce the tiny figure, that is a square. Suppose that we are given a square, and the side of the square is 1 cm by 1 cm. At the time, what is the area of the square? We just define this as the area is equal to 1 times 1, that is 1 cm squared, right? And also in different way, I can, for example, if you're talking about a piece of something, for example, let's say the area, but it's too small, at the time we may need to change this system, right? Measurement system. Instead of centimeter, we may have to use millimeter. And we know that 1 centimeter is equal to 10 millimeters, right? At the time, the same area in millimeter. What will be the same area here? The area in millimeter square will be, it is 10 mm times 10 mm, which is equal to 10 times 10 is 100, mm times mm is millimeters squared, right? So that means that 1 centimeter squared is equal to 100 millimeters squared. At the same time, also we can actually convert kilometer square, for example, into meter squared, right? Kilometer squared is how many meters squared? We know that 1 kilometer is equal to 1,000 meters. This 1 kilometer squared means it is something like this: 1 kilometer by 1 kilometer. So we are talking about a square whose length is 1 kilometer. Now we know that 1 kilometer is 1,000 meters, right? And here we have 1,000 meters. And 1,000 times 1,000, that's 1 million. Let's say it is 10 to the power of 6. And m times m, that is square meters. Okay, changing square kilometer into square meter, or square kilometers into square meters. All right, here we have square meter. The square meter is used to measure the area of large surfaces such as the floor area of a flat or tennis court or basketball court, right? And how about the hectare? Hectare is used to measure large land areas such as farms, housing estates, or even a small town, right? And what does hectare mean? Hectare, actually, we are talking about a square, let's say, and all sides are equal, and one side is 100 meters. Also, this side is 100 meters. That is called 1 hectare, right? So 1 hectare is equal to 100 meters times 100 meters, which is equal to 10,000 square meters. Okay, and kilometer square, we already talked about this. Anyway, these are the units we are going to talk and use in our problems in this chapter. Adilhan, is everything clear?
Yes.
Good. If everything is clear, let's continue. Ibrahim, Already sleepy or not yet?
No, I'm here.
Okay. Ibrahim, I have a question for you.
Yes.
Okay. If you need to ask one question to me, what question would you ask?
One question. Wait. Nothing.
Say again?
Nothing.
Nothing. Are you sure?
Yes.
How about to Adilhan, for example? Can you ask one question to Adilhan?
Yes.
Do you know Adilhan, Ibrahim?
Yeah.
Really? Do you know each other?
Yes.
How?
We are in the same class at school on math.
Oh, you are classmates.
Yes.
Yeah.
How about Selin? Are you also classmates?
No,
Selin, you go to different school or same school, different class?
I'm going to Oxford private school.
How about Ibrahim, Adilhan? What's your school name?
Sabis.
What is it?
Sabis International School.
Oh, I see. Is it a big school, Adilhan? How many students are there in your school?
In whole school?
Yeah.
I don't know.
Approximately how many? Is it more than 500?
I think yes.
So it's a big school then. How about your school, Selin? How big is your school?
You can search the internet, but Oxford School is really big, like a castle, something like this.
Like a castle? So what is the
A
exact
bit of-
name? Let me search.
Yeah, search Baku Oxford School or BOS.
Okay, Baku, Oxford
Oxford School. Yes.
School. So is it this one?
I don't see anything.
Okay.
Can you go to the? Yes, it says in the classroom, but can you go like in pictures, not in the site?
Pictures.
Yes. No, can you go back? Yes, pictures. Like this. No, back. Can you go back? This is
Back?
our
You mean in
primary
Google search?
library. Yes,
Okay.
pictures, images.
Just ask.
Which one?
Images.
Images.
Mhm.
Which one?
Here it is. This one.
This one is your school.
Mm-hmm.
Oh, I see. Who is the owner? It is Azari businessman or English people?
I know our president of school, but I don't know the owner, though.
I mean, it's like, yeah, it is European style. I don't think other buildings are like this in Azerbaijan. Is that right?
It has also a place where we can walk, so it's like a circle, but it shows just one side of it.
I see. So is it also your school, this one?
No, it's not our school. It's in Shamkir, but it's in Baku.
Yes, Ibrahim, what is the name of your school?
Sabis.
Sabistan.
Huh?
SABIS. BIS.
BIS.
Yes, and son.
That's all?
Sabi's space sun.
Sabi's son.
Yes. And write Baku.
Which one is it?
Oh, this picture our school.
All these pictures.
Yes.
Hmm.
Oh, no.
Is it your school, this one?
Yes.
Oh, it looks so big. I
Ah,
see.
no. Like right. In
Yeah,
right
this one,
there
right?
is.
This one.
No. It's not our school.
It's Sabi's Dreamland, Baku, Azerbaijan.
Ah,
Not
no,
this
it
one?
is. No, it is.
This one, right?
Yes.
Okay. Is it really like this? It's so huge.
I never saw our school in pictures, but I think it is.
There's a basketball court here and the
Yeah, I know. Yes.
tennis court and the big football fields. I see. It is so nice. Very good. So I think you must be missing your school a lot, right? When is the
Yes,
last time you
because
went to
of
school?
in October.
October?
Yes.
Oh,
March.
so March?
Yes.
Celine, the last time you went to school in March.
Yes.
Ibrahim, how come actually you went to school in October? Maybe it was not in quarantine, I think. Okay, Celine, you must be missing your school a lot. It's really actually different, right? To have class at school and spending your time with your friends and running in the schoolyards is so good. As a student, you are missing. As a teacher, also, I'm missing teaching students in the classroom. It is so different, it's much better. But now we have no choice. That's why we are having class online. Guys, let's continue. We have like 10 minutes. I will finish. After that, I have meeting. So let's just at least start this chapter. Okay, next time in our next class, we can do more. So in the first, let's just start our class with conversion of units. Okay, it's also a very important thing, converting square centimeters into square meters or square meters into square centimeters. Let's start with A. It says that express 975 centimeters squared, 975 cm squared in meters squared, right? How many meters squared? I don't know. Let's say this x meters squared. Maybe some ways you know that actually, because here meters squared means here we have 975 cm squared equals x. What does 1 meter squared? Actually, 1 meter squared is equal to 100 centimeter squared, right? So if you just understand this idea, the rest is easy. You don't have to even memorize anything here. 975 cm squared x times, if you expand this 100 squared, we know that that's equal to 10,000, right? Cm squared, that is cm squared. And both sides, cm squared, they cancel each other. So what is x? X equals 975 over 10,000, which is equal to 0.0975. So that means that 975 cm squared is equal to 0.0975 square meters, or just meter because it's less than 1. How about question B? In similar way, kilometer and meter, right? And suppose that 265 kilometers squared is equal to y meter squared, right? Again, we know that 1 kilometer, here we have 2.65 times 1 kilometer, we know that that's equal to 1,000 meters. And here we have squared. On the right hand side, we have y meters squared, right? So now if you expand this, here we have 2.65. Let me just write this in index form. We know that 1,000 is, what is it? 10 cubed. So how about 10 cubed? And here we have squared, that is 10 to the power of 6. Meters squared is equal to y meters squared. Here, just we need to find the value of y, right? So y is equal to 2 zeros, actually moves the decimal point to the right, 2 digits, right? So that is 2, 6, 5. And how many zeros left? 4. We have 1, 2, 3, 4. So that means that 2.65 square kilometers is equal to how many? 2,650,000 meters squared. And the last question, millimeters squared into centimeters squared. So 5 mm squared is equal to, let's say it is t cm squared. What is 1 centimeter? We know that 1 centimeter is equal to 10 millimeters, right? It is squared. So here we have 5. If you just expand this now, millimeter squared, they cancel out each other. 10 squared, that is 100. So here we have 100 t. From here, what is t? It is 5 over 100. That's equal to 0.05. So that means that 5 square millimeters is equal to 0.05 square centimeters. That is how we convert one unit into another unit. Units of area. Okay. Let's solve this question now. We have 1, 2, 3, 4, 5, 6. I don't think I can solve all today. Let's solve at least 2 questions, okay? And I will finish the class. So example 2. The perimeter of a rectangle is 22 centimeters and its breadth is 4 centimeters. Find its area. So first, solve this kind of question, you need to draw a picture. Let's say we are talking about this rectangle, right? And let's say its length is L, width is W, length is L. It says that the perimeter of a rectangle is this. What is the perimeter? That's equal to 2 times length plus width. That's equal to 22, right? And it says that its breadth is 4 centimeters given. So we need to find its area. From here, 2 times length, what is breadth is equal to 4. That's equal to 2 times 11. 2, they cancel each other, right? From here, what is L is equal to 7 because 7 plus 4 equals 11. So that's the first step. What is our question? Our question is we need to find the area of this rectangle. That's equal to length times width. Length equals 7 and width is equal to 4. That's equal to 28 square centimeters. Dot, dot, dot. The area of the rectangle is 28 square centimeters. These are very easy questions, just warm-up questions, okay? Another question is the width of a rectangle is 5 centimeters less than its length. So first, let's draw a picture, this rectangle, and it says that the width of a rectangle is 5 centimeters less than its length, and its perimeter is 46. Find its width and its area. Okay, so let's say the width is W. So we are going to find this. And the width of the rectangle is 5 centimeters less than its length. So its length must be then W plus 5 because width is shorter than its length, right? And also what's given here, perimeter. Perimeter is equal to 2 times length plus width. That's equal to 46, right? Or from here, we know that length plus width, if you just divide both sides by 2, that's equal to 23. And we know the actual length is W plus 5. So W plus 5, and here we have W is equal to 23. Now we have a linear equation. We know how to solve this. W plus W, it is 2W. Take 5 to the right-hand side. 23 minus 5, that's equal to 18. And from here, W is equal to 9. If W equals 9, length is W plus 5, that's equal to 14. So what is the question here? Find its width. We have already found this, and its area. So its area equals width times length. That's equal to 9 times 14. 9 times 10, 90. 9 times 4, 36. That's equal to 126 cm squared. Okay. That's the last question. Example 4. Okay, maybe we can stop here, guys. Let's continue from here next time. Maybe next time we can have a little bit longer class, okay? Because after this I have another class. I need to meet some other students. Ibrahim Adilhan Selin, if I didn't share this units exercises, I will share this now in the WhatsApp group, okay? You need to download this to your telephone or iPad or tablet, whatever it is, and try to solve these questions. I mean, these questions in chapter 7 and 8, this perimeter and area and volume and surface area, these are very, very important problems, okay? You're going to use this a lot. That's why try to practice. If possible, try to solve every question in these 2 chapters, okay? Guys, thank you very much. I will see you on Monday then. Okay. Now I will share the exercises in the WhatsApp group. And if you have any question anytime, you can just let me know. We can have a meeting one-to-one and discuss the problems. Guys, have a nice weekend. Actually, today is Thursday. See you on Monday. Okay.
Bye.
Bye-bye, Senin. Thank you.